All right, all right, all right. We got some polygon action here, ladies and gentlemen. 7.3 formulas involving polygons. Now, I think you'll be excited to know that there will be no proofs in this lesson, or maybe you'll be disappointed. I doubt the latter. I think you will be quite excited about that. All right, so these are the names of our different polygons. You do need to know these. You should memorize these. Rarely do we ever reference the 11-sided one, which is a decagon, this guy right here, but the rest of them will be referenced in problems, as well as you will be asked to maybe name something. So, for example, I might say, figure out the sum of the interior angles of a hexagon. Well, if you don't know that a hexagon has 6 sides, you aren't going to be able to complete that problem, okay? I won't just straight up ask you, how many sides does a hexagon have? All right, it'll be in the context of a problem. Okie doke? Okie doke. So, know those. They're so fun. They'll come up in different, maybe the dinner parties and stuff like that around the holidays. Family might say, hey, how about that 8-sided polygon over there? And you'll be like, you mean that octagon, Uncle Steve? Yeah, that's right. All right, so we have ourselves the definition of regular in the context of polygons. So a regular polygon is a polygon that is both equilateral and equal angular. So all the sides are congruent, all the angles are congruent. Cool? We'll mostly work with regular polygons, as that's what our formulas are designed for. So, can you name a regular quadrilateral? A regular 4-sided figure, meaning a 4-sided figure that has congruent sides and congruent angles. If you said square, you have indeed won the $1 million prize. And how about a regular triangle? That would be an equilateral triangle. Equilateral triangle. Yay! Alrighty. So, together, we're going to discover the formula for the sum of the interior angles of any polygon. Alrighty, so let's say we have a triangle, a 3-sided polygon. How many degrees are in a triangle? We know that from the other day, 180 degrees, right? We should know that from much earlier, but formally the other day. Alright, how about a quadrilateral? So a 4-sided figure, right? Could be a trapezoid, could be just a quadrilateral, could be a parallelogram, who knows? Well, how many triangles can I divide this thing up into? And when I say dividing it up, I don't want you to intersect any of your diagonals that you put in there. Really, we're just dividing this thing up into 2 triangles in this case. Each one of these being 180 degrees, which gives us a total of 360. Woo! What if we had a 5-sided polygon? How many triangles then? Well, I would have 1, 2. Oh, hold up. I can only draw 2 diagonals, right? 180. 180, 180. So we got 3 triangles in there, right? Because I can't draw any other diagonals unless they overlap. So, boom, 540. And we can do this all day, but I feel like that'd be kind of a pain in the butt to just keep on dividing these up, draw pictures and whatnot. What if there's a formula? Let's think about this. The number of triangles that you get in there dictates, you know, that multiple of 180, right? If you got 2 triangles, 2 times 180. 3 triangles, 3 times 180. Well, with 3 sides, we only get 1 triangle, right? With 4 sides, we get 2 triangles. So, and then with 5 sides, we get 3 triangles. So it's always 2 less. So if I take my number of sides and I subtract 2, that gives me my number of triangles. And what do I do with my number of triangles? I multiply it by 180. There is my formula for the sum of the interior angles. And we'll notate it officially like this. Sum of the interior angles. This is generally written with S sub I. And then just our interior angles with a capital I. Okay? So the sum is 180 times the number of sides minus 2. And the interior is that same thing, but then I'm dividing it by the number of sides, or really the number of angles, right? In that case. So sides, or you can think of it as the angles. It's going to be the same number. Sides and number of angles is the same. All right? This formula right here, we don't use that too often. Tomorrow's lesson, we'll deal with the exterior angles, which is much easier to deal with, but I will talk about that right now. Okay, and then you can just jot all these down together, because Mr. Allen's cool like that. So if I have a triangle, right, let's say it's an equilateral triangle. This angle is 60, right? Because they're all 60. 180 divided by 3 is 60. This guy right here is 120. All right? That's my exterior angle. And I would have 3 of those exterior angles. So then we'd have, wait, did I draw that right? Hold up. I want to draw that here and then here. Okay. So I'd have 120 and 120. What does that all add up to? All those exterior angles end up adding up to 360. Let's see what happens with a square. All those are 90, right? So then my exterior angles are all 90. So I get 90 on all those, and then I'd have 90 here and 90 here. You only get one exterior angle per vertex. Well, what do all those 90s add up to? Once again, it's 360. Okay, I'm starting to see something here. Let's see, if I make myself a little more room, if I did a regular pentagon, well, my interior angles of a pentagon, if I figure out my sum, which would be 540, and I divide that by 5, I would end up with 108 for my interior angles. Not 180, 108. There we go. All right. Well, that's a straight line once again, so what's my exterior angle? It's 72. All right. And again, I can do that on all of these angles, all my exterior angles. I'm going to get 72 for all those. What's 72 times 5? Once again, it's 360. So every single time, no matter how big or how many sides my polygon has, my exterior angles add to 360. So what I like to do is I like to take, if I have a question that's asking me to find an angle measure or whatever, I often use the exterior angles adding to 360 and the number of sides that I'm dealing with to help me solve that problem. And we'll talk about that when we go over some examples here. But I would jot down that exterior angles add to 360. So each exterior angle is equal to 360 divided by the number of sides. Okay, and we'll formally have that in our PowerPoint tomorrow, but I think this is helpful as we go through some of these example problems. So here it says find the measure of an angle of a regular decagon. Okay, when they say an angle of a regular decagon, they're implying the interior. Okay? All right, so if I use my interior angle formula, so one interior angle is equal to 180 times the number of sides, 10, decagon. See what I mean about knowing the names? If you know the names and the number of sides, you'll be able to do these problems. Otherwise, you're going to be in trouble. And then we're going to divide that by 10. So when I plug that all into my calculator, you get 180 times 8 divided by 10. I end up with, let's see here, 144. Okay, so that's the measure of one angle. Why don't we talk about what I was saying with the exterior angles? Well, an exterior angle always adds to 360, right? So one exterior angle would be 360 over 10. So that's 36. So if I'm thinking about an exterior angle of a decagon, right, let's just say I've got all these sides, whatever, I'm trying to find this angle here. Or sorry, that's the angle I have. And this should be 36, not 360. My apologies. Well, if this is 36, what's the supplement of that? That is 144. And boom, there you go. I personally like this method best. Okay? I find my exterior, then I find the supplement of that to get my interior. It will work every single time. But 144, regardless of which way you go there, the choice is yours, which formula you want to use. Again, exterior angles will be tomorrow's lesson along with some other stuff, but it ties in nicely today. All right, so the measure of an interior angle of a regular polygon is 108. Find the number of sides of the polygon. This is another situation where, in my opinion, the exterior angle version is easier than the interior angle version, but I will show you the interior angle version first, and then the exterior angle, and you can choose yourself. All right, so the interior angle is 108, and that's equal to 180 times n minus 2 over n, right? So if I solve this algebraically, I'm going to have 108 n equals 180 n minus 180n minus 360. So if I subtract 180 to the other side, I end up with what? Negative 72n equals negative 360. Then I divide by negative 72. Oops. And I get n equals 5. So I have a pentagon. Oh, it's actually just for the number of sides. So 5 would be fine. If I had asked you what's the name of the polygon with this information, pentagon would be the answer. So in this case, it is just 5. All right. What about if we're thinking about it with an exterior angle? Well, if the interior angle is 108, the supplement of that, 72 is my exterior, right? And what's the sum of all my exteriors? Well, 360 is my sum of my exteriors. Divide that by 72. That equals 5. That's my number of sides. I find that way to be much easier. You do have to remember that interior and exteriors are supplements of each other. But, I mean, that, to me, is a much quicker way of going about it. Choice is yours. Just want to provide you with both because Mr. Allen just cares. You know, he really cares about providing you with a quality education. You know, maybe even more information than you actually need. I don't know. I'm just crazy like that. America. All right. Here we've got the sum of the measures of the angles of a regular polygon, so the interior angles, is 1080. Find the measure of each angle. Well, I need to know how many sides there are if I'm going to figure out the measure of each angle, right? 1080 is how the total. Well, 1080 is equal to 180 times n minus 2, right? That's my total for my interior angles, my sum of my interior angles. Well, let's solve for n. Well, I can either distribute that 180 or I can divide by it right away. I'm going to choose to divide by it right away. So 1080 divided by 180 gives me 6. So when I do that, 180 and then I'm going to add 2. So I get n equals 8. So I have 8 sides. That's a checkpoint, not my final answer. Find the measure of each angle. Well, there's 8 sides, there's 8 angles. 1080 divided by 8 is going to give me the measure of each angle, right? 1080 divided by 8 gives me 135. Boom! That is my final answer. That's the measure of each angle. Cool. Awesome. So I had to figure out how many sides, which is the same as how many angles, and from there I can get each individual angle. Okay. All right, we got a doozy to finish out the lesson here. Although not a proof, still quite the doozy. 7 of the angles of a decagon, decagon has 10 sides, have measures whose sum is 1,220. Of the remaining 3 angles, 2 are complementary and 2 are supplementary. Find the measures of the 3 angles. And maybe you are sitting here and saying, Mr. Allen, hold the phone, broski. It says of the remaining 3 angles and then says 2 are complementary and 2 are supplementary. Well, I don't know about you, but 2 plus 2 is 4. And I would agree with you that 2 plus 2 is 4. However, you shall see shortly that we are only referring to 3 angles when we say that. Okay. Prepare to be dazzled and have your mind blown. Alrighty, so first off, how many degrees are in a decagon? How many degrees total for my decagon do I have? Well, 180 times 10 minus 2 would tell us the sum of my interiors. In other words, 180 times 8, that's 1440. So how many degrees are left for those remaining 3? So if I subtract 1220, that'll tell me what I'm working with. So 220, right? Okay, so that's what I'm working with for my remaining 3. Okay, so of those 3 angles, 2 of them are complementary, 2 of them are supplementary. Well, let's say this. Let's say one of the angles is x. What's the complement of x? How about 90 minus x? And then what's the supplement of x? How about 180 minus x? So I have a question for you right now. Are these 2 angles right here, x and 90 minus x, are those complementary angles? Yes, I would say they are, because they add to 90, right? And then this guy and this guy, are those supplementary? Do they add to 180? Yes. So 2 angles are supplementary, 2 angles are complementary. Oh my goodness, this is starting to make sense, I hope. Otherwise, maybe ask questions. Okay. So those angles need to add up to 220, right? So x plus 90 minus x plus 180 minus x. If I add that all up, I'm going to get 270. Oops. 270. And then x gives me minus x, and that's equal to 220. So when I solve for x here, I subtract 270, negative x equals negative 50, so x equals 50. So that's one of the angles. The complement of that is 40, and the supplement of 50 is 130. And all of those will add up to 220. 50 and 130 are supplements, 50 and 40 are complements. Yay! America, freedom, rock and roll. That was a lovely problem. Quite difficult, but soup's cool.